Hello friends, in this video lecture we are going to study the topic earthquake, right? Earthquake we are going to study here. The topic of earthquake is studied in seismology, right? This topic of earthquake is studied under what? Seismology. Seismology is a branch of science in which we deal with what? Earthquake like phenomena, right? Earthquake like phenomena. Now, what is seismology? Seismology is the scientific study of earthquake caused by PS and L seismic waves. PS and L seismic waves, right? So, the topic of earthquake is dealt under seismology, and seismology refers to the what? Scientific study of earthquake caused by PSL seismic waves. Now, need to know what are the causes responsible for origin of PSL waves. What are the causes responsible for origin of PSL waves, right? So, for the origin of PSL seismic waves, there can be two kinds of forces. One is the internal force and second external force. These two forces, internal, external, what we also call as endogenetic and exogenetic forces. These two forces are responsible for origin of PSL waves. These two forces means endogenetic and exogenetic forces initially disturb the crust, then PSL waves generate, and these PSL seismic waves wherever trouble there causes the vibration, ultimately results into earthquake. Earthquake. Right. So, what can be the definition of earthquake? Right? Sudden disturbance of earth crust. You have got about the seismology. In this discipline of science, we study the earthquake, scientific study of earthquake, and the cause of origin of PSL seismic waves, which is ultimate cause of the occurrence of the earthquake. Right? Now, the definition of earthquake. What can be the definition of earthquake? Sudden disturbance of earth crust due to PSL seismic waves caused by internal and external forces. Internal and external forces leading to cause origin of PSL seismic waves, and these PSL seismic waves results into sudden disturbance of earth crust, that is called as earthquake. That is called as what? Earthquake. So, the next point related to this topic, first of all you see the damage occurring under influence of earthquake. These kind of the damages take place. It is a road has become ruptured under influence of earthquake. Due to earthquake, the road has become what? Ruptured, completely broken, right? The next image you also can imagine here. Collapse of a large building, right? Collapse of a large building due to earthquake. Collapse of large building due to earthquake means there takes place loss of life and property. How the life and property? If the building is becoming collapsed, there are living some people, and there becomes threat on the life of those people. That's why the earthquake kind of natural disaster or man-made disasters responsible for loss of life and property. Responsible for loss of life and property. What are the causes related to the earthquake? What are the causes responsible for occurrence of earthquake? One is the natural cause. Within natural cause, there can be internal forces as well as external forces, right? Natural causes are as what? Internal forces, and the second as external forces. Internal forces related to the what? Convectional current or convection caused by magma. In case of external forces, there can be two types of forces. One is terrestrial. Terrestrial means related to earth, and the second is extraterrestrial, beyond the earth. What are the terrestrial forces, right? Terrestrial factors responsible for occurrence of earthquake. So, terrestrial factors are like landslides. If landslides occur in the mountainous region, necessarily there will take place a jerk like force, and which shake the crust. Ultimately earthquakes occur. Imbalance, erosion and deposition. Imbalance, erosion and deposition means, suppose from the Himalayan mountain system there is taking place continuous erosion, and the eroded material is being deposited in Great Plains as well as in Bay of Bengal, right. So, the material of the Himalayan region, eroded material of the Himalayan region is being deposited in the Bay of Bengal and Great Plains. In such circumstances, Himalayan zone becoming comparatively lighter, and the plain as well as Bay of Bengal becoming heavier. So, there will take place imbalance like situation that also results into a factor of earthquake. If we talk about the extraterrestrial factors are related to the meteors. If meteors collide to the earth, there is a huge probability of occurrence of earthquake. There is the huge probability of occurrence of earthquake. And the next is the natural factor. Sorry, not natural. The next is the man-made factors. In man-made causes, there are large dams, nuclear test, mining, skyscraper buildings, etc. So, large dams causes plate imbalance. Creation of large dams like Bhakhara, Nagal, Tehri dams creates huge, apply huge load and affect the zones. So there may occur the earthquake under influence of large dams. Secondly, we talk about nuclear tests. In 2017, Kim Jong, the dictator of North Korea, did a nuclear test, and due to which there resulted of an earthquake of magnitude 5.5 magnitude earthquake occurred because of the nuclear test done by North Korean country under guidelines of Kim Jong dictator. Another factor, man-made factor, as mining for the need of socio-economic development. Mining is inevitable. Mining is a kind of inevitable component. That's why mining is done. And if coal mining or the mining of iron ore is done in the peninsular region of India, and the material is being transported towards the plains, towards the plains or the mountains Himalayas, at that time there will take place again imbalance of the plate. So there will take place what? Occurrence of earthquakes under influence of mining factors too. And skyscraper buildings are similar to the what? Large dams. So these are the actually factors responsible for occurrence of earthquake, right? These are the factors responsible for occurrence of earthquake. What is a seismograph, right? What is seismograph? Seismograph, within the topic earthquake, we also study the word seismograph because many times UPSC have asked the question related to seismograph. What is seismograph? It is a kind of device, technical device or instrument which analyzes the energy flowing through in form of PSL seismic waves, and represent the energy in form of magnitude. Represent the energy in form of what? Magnitude. So we can say it is a kind of instrument which measures released energy of PSL seismic waves and represent energy in form of intensity or magnitude of earthquakes. Intensity or magnitude of earthquakes, right? There are many types of seismographs like Richter scale. There are many types of seismographs like Richter scale, Mercalli scale, Rossfeder scale, but because of most accuracy and highest precision power, the Richter scale has become most popular, and right now the Richter scale is used to measure the magnitude and intensity of earthquake globally. So Richter scale having right now global recognition. So now need to study about the Richter scale too, because UPSC have asked the questions related to Richter scale or the seismographs in preliminary examinations, right? In preliminary examinations. So what is a Richter scale? Now, something about the Richter scale. It is a kind of seismograph which measures the energy of PSL seismic waves and represent it means energy, represent it in terms of magnitude, represent it in terms of magnitude. There are 0 to 9 digits numbered on Richter scale. Total points on Richter scale are 10, while it has 9 parts. Every point, I am writing here, every points on Richter scale represents represents 10 times more energy than earlier. Means, suppose this is the Richter scale and there has been represented points between 0 to 9. We have measured the energy at point 3. Suppose this is 500 unit and on 6 there will be 500 multiplied by 10. So, it becomes as 5,000 units. It becomes as 5,000 units. So, you can understand this is the earlier point, that is 1, 3, and here this is what 4. So, at point 4 there will be 10 times more energy than the earlier, that is 3. So, the energy recorded on 4 is 10 times more, is 10 times more than the 3, and it becomes as 5000 units. It becomes as what? 5000 units. So, in many of the examinations there can be the questions related to this particular fact. So, remember it for always. After studying the Richter scale, now we know about the PSL seismic waves, because in examinations there is also asked the questions related to these waves. What is P wave, right? First of all, P waves. Very first point, it is called as primary waves, because it reaches firstly on Earth's surface due to its highest, velocity, that is around highest velocity, that is around 13.5 kilometer per second. It is also called as, point number 2, it is also called as longitudinal waves, The next, sound like waves, right? Sound like waves. Etc. It can travel, P waves, can travel in all 3 mediums, but its velocity reduces from solid towards liquid and gases. We can draw a histogram here. Velocity of P waves, highest in solid material, then liquid, and finally gaseous. The next type of the seismic wave is as S waves, right? What are S waves? These are called as secondary waves, transversal waves, and light like waves. it can travel in solid medium but get disappeared in liquid. That's why we find what? We find that's why we find shadow zone of P waves between 103 degree in the left and 103 degree in right from focus of earthquake, right. So, it is about the S waves. It is also called as light like waves. Its velocity is 60%. Its velocity is 60% of P waves, right. Its velocity is 60% of P waves. This is about S waves, and the next is L waves. What are the L waves? It is called as what? Tertiary waves. It is called as what? Tertiary waves, as reaches at third position, also known as long period, also known as long period waves, also known as long period waves. When it reaches to surface, becomes parallel to surface. Due to which it is also known as surface waves. When S waves reaches to surface, maximum destruction starts due to its maximum amplitude and presence of every waves up to now. Due to which it is also known as destructive waves, also known as what? Destructive waves. right. So, it is all about the all seismic waves PS and L. Now, the next point related to the earthquake is global distribution of earthquake, right. Global distribution of earthquake. Earthquake globally can be divided. Earthquakes globally can be divided into 4 belts. One as Pacific belt. In this belt, there occurs around 63% of the global earthquakes. Why? Because the Pacific belt is located on the margin of continental oceanic convergence, on the margin of continental oceanic plate convergence, right. So, it records maximum earthquake and maximum magnitude of earthquake. The second point relate to mid-continental belt. It records around 21% of the global earthquakes. Third is mid-Atlantic belt or oceanic belt. It records around 11% of the global earthquakes. This is the zone of mid-oceanic ridges. This is the zone of mid-oceanic ridges. And the fourth is others, means it records 5% of the global earthquakes. Others related to the zones where there is not the presence of plate margins, and earthquake occurs, right. Earthquake occurs. So, total becomes here 63 plus 21 plus 11 plus 5, total becomes as 100%. This is all about the global distribution of earthquakes, right. Global distribution of earthquake. In this particular diagram, you can easily, in this particular map, you can easily understand the distribution of earthquakes. These are the zones experiencing maximum earthquake, and this is related to the Pacific belt. This is also the part of Pacific belt, and the country of earthquake, that is Japan, is also located. Country of earthquake, that is Japan, is also located on this particular Pacific belt zone, right. So, this is the Pacific belt. The second is this one as the mid-continental belt, and the next as mid-Atlantic or oceanic mid-Atlantic belt, and the last one as others. It can relate to the Antarctica, African continent, North American continent, Brazilian highland region, or the Siberia. These all associate to the others, where 5% of the global earthquake takes place. So, it is all about the concept of earthquake. Now, need to know about isoseismal lines. What are these lines? These are the lines these are imaginary lines formed through joining of places of same magnitude of earthquake, same magnitude of earthquake, right? Same magnitude of earthquake, that is called as isoseismal lines. Suppose this is the crust. Beneath the crust there is upward moving of magma. Here magma strikes, and due to striking of magma, here PSL seismic waves originate, that is called as hypocenter, that is called as hypocenter or focus of earthquake. From this particular point, a place on surface of earth experiencing the vertical PSL seismic waves, PSL waves reaching vertically at the point that is called as epicenter, that is called as what? Epicenter. Need to know about this particular point, epicenter. Suppose this is the epicenter, right, and there are many places as A, B, C and D. These all places experiences earthquake of same magnitude, like 5 magnitude, 5 magnitude, 5 magnitude and 5 magnitude. Join these all points, we get an imaginary line. This is called as isoseismal lines. This is called as isoseismal lines, right? The next is homoseismal line. What is the homoseismal line? In the same way you can define it also. A line forming through joining of places experiencing earthquake at same point of time, same point of time. Suppose this is the epicenter, we call it epicenter. There are points like x, x dash, x double dash and x triple dash, and at these points earthquakes occur at 7 a.m. When we join these points, created line is called as homoseismal line. It is also called as homoseismal line. So homoseismal lines are those formed by joining of places experiencing earthquake at same point of time. This is called as homoseismal lines. In such circumstances, we have completed about the topic earthquake. In the next video, you will see about volcanic eruption. All the best to all of you. Have a nice time. Goodbye.